Our universe is a tapestry of wonder, woven with threads of light, mystery, and unfathomable scale. Imagine standing on a beach, gazing at the ocean, its waves stretching to the horizon. Now picture that ocean as the cosmos, but instead of water, it's filled with stars, galaxies, and vast stretches of space that defy comprehension. The universe is not just big. It's so vast that our minds struggle to grasp its true dimensions. Yet, thanks to incredible tools like the James Webb Space Telescope, we're beginning to unravel its secrets, peering into regions so distant that the light we see today began its journey billions of years ago, when the universe was just a fledgling. Let's start close to home, with our own cosmic neighborhood. Our solar system is a tiny oasis in the grand scheme of things, but even this small corner of space is mind-bogglingly huge. If you hopped into a car and drove at a steady 70 miles per hour, you could circle Earth's equator in about 15 days. That's a long road trip, but manageable. Now, imagine driving that same car to the moon. At 70 miles per hour, it would take you roughly 5 months to cover the 238,000 miles. That's a journey that feels almost within reach. But what about Mars? At its closest approach to Earth, Mars is about 48 million miles away. Driving there at the same speed would take you 63 years, your entire lifetime spent behind the wheel, just to reach the red planet. And if you set your sights on Neptune, the outermost planet in our solar system, that trip would take a staggering 4,400 years. That's longer than recorded human history. These distances show us that even our solar system, which we think of as our backyard, is a vast expanse. Now, let's zoom out further. Our solar system is just a speck within the Milky Way, our galaxy. The Milky Way is a barred spiral galaxy, a cosmic pinwheel with swirling arms that stretch across 100,000 light-years. A light-year, by the way, is the distance light travels in a single year, about 5.88 trillion miles. To put that in perspective, if you could somehow travel at the speed of light, which is 186,000 miles per second, it would still take you 100,000 years to cross from one side of the Milky Way to the other. Inside this galaxy, there are an estimated 300 billion stars, each one a potential sun with its own planets, moons, and possibilities for life. To give you a sense of scale, imagine trying to count every grain of sand on every beach on Earth. That number would still fall short of the stars in our galaxy. Let's take a moment to consider one of those stars, Proxima Centauri, the closest star to our Sun. It's part of the Alpha Centauri system, located 4.24 light-years away. If you were to board a spacecraft like Voyager 1, which zips along at 38,000 miles per hour, it would take you about 73,000 years to reach Proxima Centauri. That's not a typo, 73,000 years. Even light, the fastest thing in the universe, takes over 4 years to make that trip. This distance is why interstellar travel remains a dream for now, a challenge that pushes the boundaries of our imagination and technology. But the Milky Way is just one galaxy among countless others. Scientists estimate that the observable universe contains around 2 trillion galaxies. To grasp what that means, let's try an analogy. Imagine you're standing in a field, holding a single apple seed. That seed represents our solar system. Now picture the entire field filled with apple trees, each tree laden with thousands of seeds. Each of those seeds represents another star system in the Milky Way. Now imagine a million such fields, each packed with trees, each tree packed with seeds. Even then, you're only scratching the surface of the number of galaxies in the universe. 2 trillion is a number so large it's almost impossible to visualize, but it's a reminder of how small we are in the grand cosmic picture. Let's explore one of these galaxies, our closest neighbor, Andromeda. Andromeda is 2.5 million light-years away, a distance so vast that the light we see from it today left its stars when our ancestors were just beginning to use stone tools. Andromeda is massive, containing about 1 trillion stars, more than 3 times the number in our Milky Way. What's even more fascinating is that Andromeda is hurtling toward us at about 250,000 miles per hour. In roughly 4 billion years, our 2 galaxies will collide. Don't worry, though, this isn't a cosmic car crash. The spaces between stars are so vast that it's unlikely any will collide. Instead, the galaxies will merge, their stars dancing around each other in a gravitational ballet, forming a new, larger galaxy. This collision could spark the birth of new stars, and perhaps new planets where life might one day emerge. This brings us to a fascinating question. What is the universe made of? When we look at the night sky, we see stars, planets, and galaxies, but these make up only a tiny fraction of the cosmos. Scientists estimate that ordinary matter, everything from atoms to asteroids, accounts for just 5% of the universe's total mass and energy. Another 27% is dark matter, a mysterious substance that doesn't emit or reflect light, but exerts gravitational pull, holding galaxies together like invisible glue. The remaining 68% is dark energy, an even more enigmatic force driving the universe's expansion, pushing galaxies apart at an accelerating rate. Imagine the universe as a cosmic cake. The stars and planets are the sprinkles, dark matter is the flour holding it together, and dark energy is the yeast making it rise faster and faster. One of the most profound discoveries about our universe is its age. By studying the cosmic microwave background radiation, a faint glow left over from the Big Bang, scientists have determined that the universe is about 13.8 billion years old. This radiation is like a snapshot of the universe when it was just 380,000 years old, a time when it was a hot, dense soup of particles. As the universe expanded and cooled, those particles formed atoms, then stars, then galaxies. When we observe this radiation today, we're looking at the oldest light in existence, a relic of the universe's infancy. It's like finding a photograph of your great-grandparents as babies, offering a glimpse into your family's origins. Let's dive deeper into the structures that make up the cosmos. Galaxies aren't scattered randomly. They are organized into vast networks. Picture the universe as a giant sponge, with galaxies clustered along the edges and walls, separated by enormous voids. These walls are made of cosmic filaments, threads of gas, dust, and dark matter stretching billions of light years. Where filaments intersect, you find galaxy clusters, like the Virgo cluster, which contains over 1,500 galaxies. Our Milky Way is part of the local group, a smaller collection of about 80 galaxies, which itself is a tiny part of the Laniakea supercluster, a massive structure containing 100,000 galaxies. To visualize Laniakea, imagine a city where each building is a galaxy, each neighborhood a cluster, and the entire city a supercluster. Now picture millions of such cities across the universe. That's the scale we're talking about. Within these galaxies, extraordinary events shape the cosmos. Take supernovae, the explosive deaths of massive stars. When a star runs out of fuel, it collapses under its own gravity, then rebounds in a cataclysmic explosion, outshining entire galaxies for a brief moment. These explosions scatter heavy elements like carbon, oxygen, and iron across space, elements that are the building blocks of planets and life. Every atom in your body was once forged in the heart of a star, meaning you are, quite literally, made of stardust. Then there are black holes, regions of space where gravity is so intense that not even light can escape. At the heart of most galaxies, including our Milky Way, lies a supermassive black hole, with masses millions or even billions of times that of our Sun. These cosmic giants shape their galaxies, pulling stars and gas into swirling disks and sometimes ejecting powerful jets of energy that can be seen across the universe. Quasars, powered by supermassive black holes, are among the brightest objects in the cosmos, emitting energy equivalent to billions of suns. Some quasars are so distant that their light has taken over 12 billion years to reach us, offering a window into the universe's early days. Let's pause to consider the cosmic voids, the vast empty spaces between filaments and clusters. These voids can span hundreds of millions of light years, containing few, if any, galaxies. They are like the deserts of the universe, seemingly barren but potentially hiding secrets. Some scientists believe that over billions of years, These voids could give rise to new structures as gravity slowly pulls matter together. The interplay of voids, filaments, clusters, and superclusters forms a cosmic web, a delicate balance of creation and emptiness that defines the universe's architecture. Now, let's address the big question. How big is the universe? The observable universe, the part we can see, is about 93 billion light-years in diameter. This is because light from the farthest objects has taken billions of years to reach us, and during that time, the universe has been expanding. But the observable universe is just a bubble within the larger cosmos. Beyond it lie regions we'll never see, because their light hasn't had time to reach us, and due to the universe's expansion, it may never will. Some estimates suggest the entire universe is at least 250 times larger than the observable part, and it could even be infinite. To wrap your head around this, imagine standing in the middle of a forest, able to see only a few miles in every direction. Beyond your view lies more forest, stretching farther than you can imagine, possibly forever. This brings us to a profound idea. The universe might be infinite, not just in size but in possibilities. If the universe is infinite, there could be countless other worlds, perhaps even duplicates of our own Earth, with versions of you and me living slightly different lives. This idea, known as the multiverse, is speculative but grounded in some interpretations of cosmology and quantum mechanics. It's a reminder that the universe is not just a place but a story, one we're only beginning to read. Let's zoom back to our own planet for a moment. Earth is a pale blue dot, a fragile speck in the cosmic ocean. Yet, it's the only place we know of that harbors life. The search for extraterrestrial life is one of the most exciting quests in science. Planets orbiting other stars, known as exoplanets, are now being discovered by the thousands, thanks to telescopes like Kepler and TESS. Some of these planets lie in the habitable zone, where conditions might allow liquid water, a key ingredient for life as we know it. Could there be other civilizations out there, gazing at their own skies, wondering if they are alone? The Fermi paradox asks why we haven't seen signs of intelligent life despite the universe's vastness. Perhaps life is rare, or perhaps our signals haven't yet reached others, or theirs haven't reached us. The universe is patient, and we're just beginning to listen. Another fascinating aspect of the cosmos is time itself. The universe operates on timescales that dwarf human experience. Stars can burn for billions of years, while black holes can persist for trillions. Meanwhile, our lives are a fleeting moment, a single note in the cosmic symphony. Yet, in that brief time, we've built telescopes, launched probes, and begun to understand the universe's story. The James Webb Space Telescope, for instance, has revolutionized our view of the cosmos. Its infrared eyes can peer through cosmic dust, revealing newborn stars, distant galaxies, and even the atmospheres of exoplanets. It's like giving humanity a pair of glasses to see the universe in a new light. Let's consider one last phenomenon, gravitational waves. These are ripples in the fabric of space-time, caused by massive events like the collision of two black holes. First predicted by Einstein, gravitational waves were detected in 2015 by the LIGO Observatory, opening a new way to study the universe. Unlike light, which can be blocked by dust or gas, gravitational waves pass through everything, carrying information about events that happened billions of years ago. It's like hearing the universe's heartbeat, a rhythm that tells us about its most violent and dramatic moments. As we reflect on all this, we're left with a sense of awe and humility. The universe is vast, ancient, and ever-changing. We are a part of it, born from its stars, shaped by its forces. Every discovery we make, from the cosmic microwave background to the galaxies beyond our reach, is a step toward understanding our place in this grand narrative. The universe isn't just out there, it's in us, in the atoms of our bodies, in the questions we ask, in the dreams we chase. If the mysteries of the cosmos spark your curiosity, if you find yourself gazing at the stars and wondering what lies beyond, then join us on this journey. Subscribe to our channel, give this video a like, and hit the notification bell to stay updated on the latest discoveries about the universe and our place within it. Together, let's explore the wonders of the cosmos, one star at a time.